Okay, so we're going to take a look at chapter 4. Chapter 4 is called Graphs and Transformations, and lots of the skills in this one are related to what you did in chapter 3. So in chapter 3, we talked about solving simultaneous equations graphically. So the chapter is sort of divided into these main areas. So the first part really is understanding some different types of graphs. So we've got cubic graphs up here. So cubic graphs, you may have seen this at GCSE. They sort of look something like this. They kind of go flat usually, well, or not necessarily. Sometimes they come back and then turn again on themselves, something like this. Quartic graphs will be brand new to you. So quartic graphs, we're talking about when the highest power is x to the power of 4. So cubic is x to the power of 3 and x to the power of 4. And reciprocal graphs, again, is another one that you may have seen at GCSE. Sort of, they roughly look like this. And as we're sort of finding out what these sketches look like, one of the things we might do is we might sketch more than one graph, or we might be interested to know about intercepts. So we talk about points of intersection. And finally, we talk about how to transform graphs as well. So we're talking about here about stretches, translations, reflections, all this sort of stuff. Quite similar to GCSE. So we're going to describe this sort of idea then as looking at polynomial graphs. And what is a polynomial? Well, it's something like what we have here on the screen. So you've actually dealt with some polynomials already in the previous chapters, where the highest power was 2, or an x squared, a quadratic, okay? And more generally, we're sort of looking at what happens when the highest power is 2 and 3 and 4 and so on. Linear fits into this as well when there's just a 1x. This is sort of chapter 5, the chapter after this mainly though. Quadratics we sort of did before, and 3 and 4 is where we're going to focus on. And we could go further, but that's not in this specification. So one point to start with is looking at perhaps the order. The order means the highest power of x, okay? So if the order is 2, it means the term with the greatest power for x is x squared. So this is an x squared, this is an x cubed, and so on. And one thing we might notice is the number of turning points and the order. It seems to be following this pattern that it can have, let's describe it as n minus 1 turning points. The order is 2, 1 turning point, 1 turning point. Order is 3, 2 turning points. However, notice this does not always need to be the case, and we'll look at sometimes why this is not always the case. If the order is 4, notice we can have even more turning points. And we should begin talking about some general patterns of their shape. So this screen perhaps looks a little bit complicated, but let's just bear with it a second. So if the order is 2, if there is an x squared term, and a is greater than 0, well, all they mean here is that this is a positive. So if we have a positive x squared, we should know already, it forms this sort of general shape. Or if a is less than 0, in other words, if a is negative, okay, we have this sort of hill shape. And we want to know what happens as well with other powers. So let's think about x cubed. So what happens if you have a positive x cubed? Well, if you put in an x here, it's a negative, you'll have a negative times a negative times a negative, because you multiply it by itself 3 times. So very, very, let's sort of say, very, very small values will give you negatives. And what about very, very large values or large positive values? Well, sort of imagine 100 or something, 100 times 100 times 100. This would be positive, and it would be a large number. So we could derive this shape. For very small numbers, for very negative numbers, we're going to have a very negative. So for a very negative x, we're going to have a very negative y. And for a very positive x, we're going to have a very positive y. And perhaps it might make sense that going the other way, we have a falling sort of cubic. So you need to be aware of the general shape of these so that you can sketch them. because this is the general shape is what they're expecting to see. For a quartic, imagine something to an even power, like the power of 4. If this were a negative, it would be a negative times a negative times a negative times a negative. So even if you put negative values in here, you can get positives. And positives would also give you positives. So if we have a normal x to the power of 4, we would expect to see sort of these positive tails going off to the side. And notice that's quite similar to a quadratic. It may have more turning points, it might look more complex, but the general shape is what we're looking for. And likewise, if we turn this upside down, so if a is a negative number, we would get like before with the negative x squared. Just so you can sort of see what happens, you don't need to know this, but this would be an x to the power of 5. So in general, what can we say? Well, if we have a positive quadratic or cubic and so on, we talk about odd powers or odd orders. We talk about them normally rising or maybe falling. And if the order is even, we talk about the tails. So here we talked about upwards tails and downwards tails. And this is what you need to see in your diagrams. So we can kind of put this together with our understanding of roots as well to draw these. What do I have here? X, and then a minus x and an x. If I multiply this out without doing the whole thing, I know I would get a negative cubic. What else can I quickly work out? If I look at the numbers only, minus 2 times 1, so that's minus 2, times 1 again is minus 2. So I know that a negative cubic goes down. I know that the y-intercept is minus 2. The roots, what are these? Well, this is where it crosses the x-axis, where it crosses y equals 0 here. And this is going to happen. This will be equal to 0 when any of these brackets are equal to 0. So notice, if I put x as 2, this whole bracket becomes 0, and this must be a root. Likewise, if x is 1 or if x is minus 1, all of these are roots. So I can put this all together, a falling cubic with a y-intercept of minus 2. Roots are where y equals 0. It must go through these points here, and these are all sort of regular roots. So the graph goes from one side to the other, one side to the other, one side to the other. Let's do another one. So x all being cubed. This is an x cubed. There are no negatives here, so this is a positive x cubed. The intercept, if you multiply all the numbers, minus 4 times minus 4 times minus 4, you will get minus 64 at the end. So it's an uphill rising cubic. Minus 64 is the intercept. But what about the roots? You can probably see from looking at it quickly that x equals 4 is an interesting value. But this is not a regular root. It's not a root where it just goes from one side to the other. You may remember, for example, repeated roots where things bounce back. That's when you have a power of 2. So what's the power of 3 going to look like? Well, this is a triple repeated root. So we have a new idea here. At this point here, you're going to see a point of inflection. We know minus 64. We know the rising shape. So the only way that we can get from this side to this side, when we know that it rises, is it must sort of make its way over the x-axis. So the point of inflection describes what happens here, where the gradient goes completely flat before returning to the main journey. So this is one thing that you need to be able to look out for, a triple repeated root. This shows a point of inflection that you'll learn about later in the course. Some other quick examples for you to have a go here on the board. Remember that if something is squared when it's factorized, this is a repeated root. So I'll leave you to pause the video here and quickly have a go at following the same steps as before. So I'm going to assume you've done that. So a negative downhill, we should get a minus x cubed from here. Roots at 2 and then a special root at -1. Y-intercept is 2, which gives us all this diagram. So notice here we have a repeated root. And on the right-hand side, this is slightly problematic because x squared here, this is a little bit like I'm writing x plus 0 squared. So the shape is fairly easy to get. Hopefully you can see that this means 0 is a root, and because it's squared, it's a repeated root. Okay, it's sort of easier to see when you write it in here. The y-intercept, though, is actually also 0, because if you do 0 times -1, so 0 twice here, and then the -1, you'll also get 0. So this one looks a bit like this. The key features we want are the roots, and if there are any y-intercepts, we would want to know those as well. Okay. And on the board, there's sort of an example of an exam question that uses some of these ideas. So pause the video here and just have a quick look, a quick read. So what we need to do is sometimes we need to go backwards. So if -1 is the root, that means one of the brackets is x plus 1. If 2 is a root, we can go backwards. It's x minus 2. However, this is a repeated root, so it's actually squared. So we can say that the equation of this is x plus 1 multiplied by x minus 2, all being squared. And then we can find out these key values here. Okay. So to sum up then, we have ordinary roots, repeated roots, and roots that give us points of inflection. So straight over, going over but coming back, going over but coming back, but going over. And the next section then is on quartics. So this idea is very, very similar to before. You multiply all of your x's to find the general shape. Roots are done by looking at the factorized forms or factorizing sometimes yourself. So 0, -1, 2, and 3. These are all regular roots. The y-intercept is by multiplying all of the numbers. Careful here though, one of the numbers is 0. Okay, there is a 0 here. So we can draw this one. Again, another example. 2, -1, and 3 are the roots. 2 is a repeated root. The shape, x squared, x cubed, so minus x to the 4, tails downwards. Roots we've discussed, and the intercept, -2 times -2, times 1 times 3. Put it all together, and this is what we get. 2 more examples on the board. Quickly pause the video and have a look. Okay, repeated roots here at 0, -1 and 1. This one should be symmetrical. And over here, 3 is a point of interest, -1 is a point of interest. Careful, the negative here though will mean that this has negative tails. Why? Because this is x to the power of 4 when you've taken it all into account, but at the end, as bit of maths says, okay, this is going to come after the indices, multiplication of -1, okay, so the tails are down. And you should now be in a position to have a go at exercise 4A and 4B from the textbook. If you're doing the alternative questions, be aware there are some for part C that we'll discuss in the next video.